Hey everybody, this lesson is the law of cosines. In the last lesson we did the law of sines, and that let us solve triangles, any triangles, whether they're right triangles or not. But sometimes, you guys, we can't use the law of sines if we don't know an angle and the opposite side. So here, how can we use the law of cosines to find the measures of any triangles? Okay, so in the law of sines, you guys, it allowed us to solve triangles if we knew an angle and the opposite side, but sometimes it won't work if we know a side and an angle and a side, or if we know three sides. And so what we have to do is develop some new formula, which is called the law of cosine. So here we go. So here's triangle ABC. So let's go ahead and draw the altitude from B right here, and I'm going to label this down here D and label some X's. And so if this whole thing is B, then this is the rest of B. So if that's X, this is B minus X right there. And of course, the altitude is H, which stands for height right there. So let's go ahead and use our Pythagorean theorem for this right triangle right here and this right triangle. So remember, this is the hypotenuse right here, and this is the hypotenuse here. So this squared plus this squared equals this squared, and then over here this squared plus this squared equals this squared. Okay, so we get those two equations right there. Okay, now check this out. B minus x squared. I'll do this on top right here. B minus x squared is B minus is B minus x times B minus x. So b squared minus bx minus xb, which is minus bx, and then negative times negative is a positive. So this becomes a minus 2bx right there. So I'm going to go ahead and replace that right there. Okay, now notice here we have x squared plus h squared. Here's x squared plus h squared. So what we're going to do is substitute that in. I'm going to put c squared in right here. Okay, and this is going to help us develop the law of cosines rule. All right, so so in triangle ABD, sorry guys, excuse me. So the cosine of A is adjacent over hypotenuse. Remember, cosine is adjacent over hypotenuse, so x over c. So let's go ahead and solve that for x, and then so we're going to multiply both sides by c, and we get c cosine of A equals x right there. Okay, all right, so now look, here's x right here. We're going to substitute this in right there. Okay, so this is helping us develop the law of cosines rule. Okay, so subbing that in, we get that, and then so more cleanly, if we clean it up, we put the b squared plus c squared minus 2bc cosine of A. Now check this out. This side squared is going to be this cosine of this angle right here, okay? And then it's all the other letters in here. So a squared equals b squared plus c squared minus 2bc cosine of A. All right, so that'll work on all triangles right here. So the law of cosines, there's a squared equals b squared plus c squared minus 2bc cosine of A. Now if I did b squared would be a squared plus c squared minus 2ac cosine of B right there, okay? All right, and then if we did this one right here, so c squared would equal a squared plus b squared minus 2ab cosine c. Okay, so these letters match up, which just means this is the side length opposite this angle, and it's all the other pieces that go along in there. Okay, all right, so let's go ahead and solve the triangles right here. So here's the first one right here. Okay, so we can't do the law of sines because we don't know this angle. Okay, we need a side and an angle opposite that. So here we got to do the law of cosines. Okay, so here we're going to go b squared equals 5 squared plus 7 squared, or 7 squared plus 5 squared, minus 2 times 7 times 5 times the cosine of that right there. All right, so if we plug all that in our calculator, now we'll understand later why this is negative, you guys, so hang in there. But the cosine of 100 is negative 0 or negative 0.17365. Okay, and then of course 7 squared and 5 squared, and then if we clean that up, we get that, and so that's what b squared is. So b is the square root of that. So let's go ahead and put that in there. Now we can use sine ratio, you guys. So the sine of 100 over 93 equals the sine of A over 7. It also equals the sine of C over 5. Once we get one angle, then go ahead and set up your sine ratios and solve, you guys. So the sine of 100 is 0.9848, and then over this one, and then now we can cross multiply, same with this one here. So when we cross multiply, we get that. Then we're going to divide both sides by 9.3, and so we get the sine of A equals 0.741, and the sine of C equals 0.526. Okay, I'm going to go up here and use this space right here, okay? So the measurement of angle A is inverse sine of this number, and the measurement of angle C is the inverse sine of this number. So punch that in your calculator. Make sure you're in degrees mode. If you're not getting those numbers, chances are you're in radians or gradians mode, and you just need to learn how to put that back into degrees mode. If you have a scientific calculator, look for the button D or G, which stands for degrees, radians, and gradians. All right, and just make sure it goes in gradients form. All right, so let's, here's another triangle right here. Okay, so they don't give us a picture. They just give us B is 23, C is 18, and the measure of angle A is 173. Okay, we can't use sine ratio because we don't have side length A. We need the angle and the side opposite, okay? So let's go ahead and set up cosine ratio, and since we have this right here and we don't have side length A, let's do the A squared. So A squared will equal B squared plus C squared minus 2 times BC times the sine of that, okay? And that'll at least get us a side length that's opposite an angle right there. Okay, so let's go ahead and plug that in, and then if we do that correctly, we get A squared is about 1674.83, so square root that, and we get about 40.9. Now we know an angle and a side opposite, so we can use our sine ratio. And we could have done the sine of C over this, but I just chose the sine of B over this right here, okay? So the sine of C gives us that right there, and then cross multiply, and then we divide, and so angle B is going to be shift side, so if we do that, we get about 3.9, okay? So a triangle adds up to 180, so we can find that final angle by subtracting it from 180, and we get about 3.1 degrees, okay? So I noticed your book did law of cosines, and I checked and spent, I don't know, 20-30 minutes on it, and their answer was like 4.5 for this one right here. And I don't know if it's the round off error or whatever, but anyways, you might just change just a little bit right there. Okay, if you're in my class, that's going to be your assignment. Take care.